In the previous video, you have learned the measures of central tendency, which are the mean, median, and mode. In this video, we shall explain the other summary measures that covers measures of variation, measures of position, and measure of skewness. Before we dig deep with the next measure, let us consider the following sets of data. First set of data contains the values 9, 10, and 11 with mean equal to 10. The second set of data consists of the values 1, 10, and 19, which also has the mean 10. If we check the median of these two sets of data, the median would be 10 for both sets, while both sets do not have a mode. Now, if these two sets have the same measure of center, what could be the difference between the two sets of data? Now observe that the two sets of data differ on how they are spread or how they are dispersed. If you look at the first set of data, the values are very close to each other, or shall we say compact. For the second set of data, we can say that the values are spread, or it has a higher range of values. So two or more sets of data may have the same measures of center, but they may differ regarding measures of variation. Any measure describing how spread the given observations relative from the mean is a measure of variation. These measures include the range, variance, and standard deviation. Before we explain the measures of variation, let us consider the following situation first. Consider the following measurements in liters for two samples of orange juice bottled by companies A and B. Let us assume that these companies both advertise that the contents of their bottles is 1 liter on the average. So if you are looking for consistency, in which company would you buy based on the following values? Now observe that the values in A are more compact than the values in company B. The values in company B have a higher range of values compared to A. So if we are looking for consistency, then we must buy orange juice or bottled orange juice from company A. The first measure of variation is the range. The range is the difference between the highest and the lowest value in the dataset. Let us have an illustration for the range. Consider again the values for companies A and B in our example from the previous slide. Let us compute the range for each of the datasets. For company A, the range would be 1.11 minus 0.94, which is equal to 0.17. While for company B, the range would be 1.14 minus 0.88, which is 0.26. So observe that the company B has a higher range of values than company A. However, the range is not a good measure of variability because it only considers two specific values in the dataset, which are the highest and the lowest values. It doesn't tell us anything about the variation of the values in between the highest and the lowest values. Since the range does not use all the values in the dataset, we shall use a quantity called variance that is a reliable measure of variation than the range. The variance of a population data is the population variance. It is denoted by sigma square. On the other hand, the variance of a sample data is called sample variance and is denoted by S squared. The population variance is generally unknown, while the sample variance may be obtained from quantitative data of survey results. The formulas are shown on your screen. We also note here that the variance is always non-negative. Furthermore, the variance can be used to compare variation or consistency of two or more sets of data. The lower variance means higher consistency. However, if the values of a dataset are in the units measurement, the variance is in the square unit measurement as seen in the squared difference in the formula. Let us have an example. Consider again the data about the two companies that sell bottled orange juice. The sample variances and sample standard deviations are shown on your screens. it can be observed that company A has more consistent values because its variance and standard deviation are lower than company B. The computation of the variance may be done using calculator or using Excel. The next summary measure is measure of position. This measure tells the rank or standing of a dataset value relative to all the values in the dataset. Percentiles, deciles, and quartiles are measures of position. Percentiles divide a set of data into 100 equal parts. It is denoted by P with a subscript I, where I runs from 1 to 99. To get the ith percentile, we must get its position relative to the given dataset. The formula for the position is shown on your screens, where n is the number of observations in the dataset. The position of the ith percentile could be a whole number or a decimal number. If the position is a whole number, then the ith percentile is the average of the values that can be found in position m and position m plus 1 in the arranged set of data. For example, if the position is 5, then we shall get the average of the 5th and the 6th value in the dataset to obtain the ith percentile. On the other hand, if the position is a decimal number, round this up to the nearest whole number. For example, if the position is 6.3, then we round this up to 7. Then, the value in the 7th position in the dataset is the ith percentile. Let us have an illustration. The following are the scores of 12 students in an exam. Let us compute for the 25th percentile and the 60th percentile. To compute for the 25th percentile, we need to arrange first the dataset in increasing order. And then, we solve for the position of the 25th percentile using the formula I over 100 times n. So substituting 25 and 12, we get 3. Since the position is a whole number, the ith percentile or the 25th percentile would be the average of the 3rd and the 4th values in the dataset. These values are 65 and 69. Its average is 67. So therefore, the 25th percentile is 67. To interpret this means that approximately 25% of the dataset would be lower than 67. Or equivalently, we can say that approximately 75% of the dataset is higher than 67. For the 60th percentile, the position is computed as 7.2. Since this is a decimal number, we need to round up 7.2 to the nearest whole number, which is 8. Therefore, the value in the 8th position in the dataset would be the 60th percentile, and this value is 78. To interpret this means that 60% of the dataset is lower than 78, or approximately 40% of the dataset is higher than 78. The next measures of position are deciles and quartiles. Deciles divides the set of data into 10 equal parts, while quartiles divides the set of data into 4 equal parts. Now these two measures, the deciles and the quartiles, are actually equivalent with percentiles using the relationships that you see on your screens. For deciles, d sub I is equal to p sub 10 times I. This means that whenever we have the second decile d sub 2, it's equivalent to the 20th percentile. For quartiles, if we have q sub 3, it means that it is equivalent to the 75th percentile. Using again the dataset in the previous example, you can do on your own to compute for the 4th decile and the 3rd quartile. As you can see on your screens, the 4th decile is equivalent to the 40th percentile, and the 3rd quartile is equivalent to the 75th percentile. Since you already know how to compute these percentiles, you can do this on your own. The last summary measure is the measure of skewness. This measure describes the shape of the distribution of the values in a dataset. The distribution may be symmetric, it could be skewed to the right, or it could be skewed to the left. The formula for the coefficient of skewness is given by Sk equals 3 times the quantity of the mean minus median divided by the standard deviation. To interpret this, if the skewness is equal to 0, then we can say that the distribution is symmetric. If the skewness is positive, then the distribution is skewed to the right. This means that the mean is greater than the median, or this means that there are more values that are below average. Now, if the skewness is less than 0, then the distribution is skewed to the left. This means that the mean is lower than the median, which means that there are more values in the dataset that are above average. So now you have learned everything about the different summary measures that includes the center, variation, position, and skewness. In the next set of videos, you will learn about counting techniques, which is a prerequisite for probability.